Hi, I'm going to show you how to build a simple robot buggy using a Raspberry Pi and program it with Python. So the first thing I'm going to go through are some of the materials that you'll need. So I ordered this kit off Amazon that came with mostly everything that I needed. I did find that one motor did drive smoother than the other though, so you might want to order the parts individually because you'll probably get better quality parts, but it's a bit cheaper and faster to order the kit. So other than that, you'll need to grab a Raspberry Pi. I ordered the Raspberry Pi 3B Plus because it has a lot of USB ports, tons of GPIO pins, which I only used a couple in this project, but if you get into doing more complex things, you'll definitely find they come in handy. It also has an HDMI port, a micro USB port, and audio and Bluetooth connectivity. So it's a great machine, and if you want to do other things with your Raspberry Pi afterwards, this is definitely a good one to grab. Another thing you'll need is a power bank and also a micro USB cable to go with it. Just a little short one would be fine. You'll also need some sort of double-sided tape. So you also need 4 AA batteries, a tiny screwdriver, a motor controller board. You may want some extra wires as well. Something I would do before I got into the construction of the robot would be to connect the wires to the motors. So I've designated this one as my right one, this one is my left one. You can imagine the front of the robot would be up here. So you're going to have the black parts facing forward when you connect it to the body. And the reason I've designated these to specific spots is because there's different poles on the motors. As you can see, there's a small little dot right there. So the other one has that as well. And when I found with this motor that when that dot received power, it drove clockwise. Then with the other one, when that dot received power, it drove counterclockwise. So because I wanted them both to drive the same way when they were receiving power on the dot, I flipped around the wires so that when the red wire received power, red would correspond to forward. So without any code running, if I just sent power to the red wires, they would drive forward. If I sent power to the black wires, it would drive backwards because it's just the opposite way. So once you figure that out, you can put the wires on through the clips. You can either just twist them or you can solder them on there. Obviously, it would be stronger if you soldered them, but it's up to you for sure. The first thing you'll want to do is attach the battery pack to the body piece. So this is just a little piece of double-sided tape. I had to hold some wires back. So then the battery pack goes down here. Another thing you can do with these wires, you'll have to strip the ends. It might not be a bad idea to put solder on the ends and just to make them a little stronger. And then once you have that there, you'll have one bolt go in this little hole right here on this end and one on the other side. And they'll come through on these slots right here. And then you'll just put a nut on the end to keep it secure. You want to double check that the motors will drive the right way before you attach them onto the body. Here's an easy way you can do that. So I've twisted all of the red wires together and I just have the black wire sitting here. If I touch the wire here, this motor will run and I can see that when I touch it, it runs in the direction that I've indicated with that little arrow. And then with the other one, same thing. Attach the red wires. Then you'll take the black wires, one from the right one and one from this one, touch it together. And same thing with that one. You can see it ran the way that I have this arrow indicated. So that means that if I want them to all... So you want to be careful not to let these ones touch, by the way, when there's batteries in there. Sometimes if it makes it easier, you can just pop one of these out. Then you have the peace of mind knowing that there's no power running through there because I just broke the circuit. So now that I know the way these each run, this one runs this way, and this one runs this way, I'll have them positioned like that. This is the front. This is where the front of the robot will be. Now that we know which ways the motors spin, we can attach them to the board. So when you look at your board, you'll notice that there's a wider end and a narrow end. So the narrow end is going to be the front of your robot and the wide end will be the back. So you want the black parts of the motors facing forward, so they'll attach something like this. And make sure you have your right on the right and your left on the left. So to attach them, you'll take these little T pieces and you'll see the little slots right here. So those will just pop right through there like that. and then you'll see the little divot on the side right here. The other piece is going to go like that, and you'll do the same thing on that side. And then you can take these long bolts like this, and you're going to put them through the holes of there, and you'll see that there's holes on the side to match. So you'll put it through like that and do both of them, and then it will go through the other hole on this T-piece, and then you can secure it with a bolt on the, or a nut on the end. So I'll do that really quickly right now. Once you've got your motors attached, the next thing I would do would be to attach this wheel to the front. So when you look at the instructions that come with this, they're a little hard to follow, but I did notice that they wanted to use these long pieces. Those pieces would just bring it down to the ground so your robot sits level. I didn't use them there though, so my robot kind of sat with a bit of a slant, so its nose was down a little bit, because I wanted to use those to bump up my motor controller board on top. So it's up to you how you do it, but if you want to follow how I did it, I took these small little bolts right here, and I put them through the little holes of this, like that. And then you'll notice there's some holes up here, so you just pick the ones that make a square. And then I attached these long, kind of gold colored ones on top. So I'm just going to do that really quickly right now. So this next step I did was just kind of for personal preference. It's kind of odd actually, but I took this little piece of cardboard and I set it right on top of this, just like this, because I wanted my motor controller board to sit on top and I didn't want it to slide forward when I had my robot driving. So I took these little screws again, or bolts I should say, and I put little holes in this piece of cardboard and I just put them through like this, and then I would put it into each of the little gold things underneath. So I'll just do that really quickly. So once I have this screwed in, I'm just going to put this little box that I made right on top. So you can see it's a little rough looking. It's just masking tape and a nice T-box. But I just wanted something to sit on top of this so I wouldn't have my motor controller board directly on the bolts or on the battery pack, and I didn't want it to tip off the sides. So this little box just goes in with this double-sided piece of tape, and it just sticks right in there. It may not be as strong anymore because I've taken it off a couple times, but if you just kind of put it on there, get it nice and secure, then you can put your motor controller board right in the little box so it's nice and snug. That way it won't tip out as the robot moves at all. There's no way it's going anywhere. And it gives a little bit of protection on the sides. And you can see when I put the little risers on top, it makes the motor controller board sit up a little bit higher as opposed to having this wheel down lower on the bottom, because it still functions perfectly fine if the nose of the robot is down a little bit. So the next thing I would do would be to attach the power bank. So like I said, I put a piece of double-sided tape on the bottom of it. Easy enough. I just put it in like this. I wanted to make sure the ports were facing out though, so I can plug things into it. And I put it like this. This is the only way it's going to fit actually. So there's not really much you can do. You just kind of press it on there. Mine's not completely centered, but it doesn't matter. So you have that secured on there. And then you can put the Raspberry Pi on, and I would have the ports facing out, same thing. And you can just, again, there's a piece of double-sided tape on the bottom. Stick it on. Then, because I have it positioned like this, this micro USB cable will be able to reach. It'll be a little bit of a stretch, but you can plug it in there, and you can plug it into the power bank, just like that. Sorry, one thing I forgot to tell you earlier is you'll come to find these little pieces. So these just go on the motors. I'm just gonna flip it right upside down. These go on the motors on the inside on these little white pieces, and you'll want to put kind of the side with the lip out towards the motors. And you'll just push it on like that, and then do the same on the other side. And then they'll kind of line up with these holes right here. You can see there's kind of like these little crosses cut out. So they'll line up right with the long part of those crosses. And then after that, you get to finally put on the wheels. That's a pretty exciting part. So those will attach right to these white parts sticking out here. I pop the motor controller board back in, and you can see it's starting to finally kind of look like a robot. So the next thing you're going to do is you're going to take these wires from the battery pack, and they're going to be connected to the motor controller board, because the battery power is what powers the motor controller board and the motors. So the power from the battery pack is going to go through here to the motors and turn the wheels. So you want to connect that to the board. So when you look at the board, it has a couple labels on the bottom. So you have 12 volt, ground, and 5 volt. You won't be using the 5 volt, and 12 volt is kind of like the equivalent of a VCC. So that's where the power is actually going to be going in. You'll also want to put a grounding wire on to keep things safe, just in case some sort of current does escape. So on your board, on your battery pack, the black is already your grounding wire, and this one's going to go into the VCC or the 12 volt. So you're just going to loosen the screws, and you're going to pop the wires in there. If you want to put a little bit of solder on the end of the wires, that's probably a good idea. So they just go in to the little gap, just like that, and then you screw it down. So make sure black goes in ground and red goes in 12 volt. All right, so now you got power going to the motor controller board. Well, you will once the batteries are in there. So now you want to connect these wires of the motors to the controller board. So again, I'll pop this out again, sorry. You'll see that there's two kind of banks on the side, one for each motor. So then same thing, out 1 and out 2. So you're going to put one of them in out 1 and one of them in out 2. I'd probably be consistent with this and say I'll probably put red in out 1, and same thing, you'll want to put the same one in the out 1 here. So I'm just going to quickly put those into there. Now that you got that set up, you get to set up the wires connecting the Raspberry Pi and the motor controller board. So you can see down here, it's a little hard for me to show you, but it says these are your input 1, 2, 3, and 4. So those are going to correspond to the outputs 1, 2, 3, and 4. So now you need to pick which pins on here you're going to connect those to. So I found this handy little chart that I'll put up right now to show you some of the pins. GPIO stands for General Purpose Input Output. So when I put these wires on these pins here, in the code I've designated these as outputs. So in my code I'll tell it to output power in a specific pin. It will take the power down this wire to the motor controller board. So when you're putting these on, you have to make sure you're putting them on the proper pins. You want to pick the general GPIO pins. You don't want to use the ones that have other information in the brackets afterwards. So I picked number 33, which is right here, as one of mine. So I put the brown wire on there. I use the colors just because it's a little helpful to refer to each color instead of the pin number. In your code, you'll have to refer to the pin number, but putting little comments with the color of the wire I found was really helpful. So then pin number 32 will be orange. So 32 is right here. Again, refer to the chart when you're doing this. It will help you a lot. I'm also using female to female wires because they're going to connect on these pins and go over here onto those ones. So beside my orange one, I have a gray wire on pin number 31. And then I have my ground wire, which is a female to male one, because this is going to be going into this motor controller board over here, but this end's going to be on the pin, and it will be on pin number 30. And then number 29 will be purple. That's another GPIO pin. So once you have those in, you'll hook them up to the motor controller board. Next thing you're going to do is you're going to hook up your grounding wire into the grounding slot along with this black wire from the battery pack here. So you can have more than one in there, that's all right. So when you go to attach the wires from the Raspberry Pi to the motor controller board, don't worry about where you put them, because I think it's more of a headache to try and figure out what they do based off your circuit rather than just testing it with your code. So once you get to writing the code, you can send power through each individual pin at one time, and then you can find out which one each of these inputs does. And then you can switch around these wires and change it into the order that you want after you determine what function each of these input does. So the next thing you're going to want to do is hook up your Raspberry Pi to an external monitor and boot it up, and also hook up a keyboard and a mouse. So then you're going to go and you're going to open a blank editor. I have my idle with a script on here already, which I'm just going to go through, and I would recommend you write something pretty similar. So you can see I'm just importing some modules up here. Import time, rpi, GPIO as GPIO. That's just something you have to do. I've turned the warnings off just because sometimes you will get warnings. I just didn't want to see them. And then when I'm setting the mode to GPIO.board, that means I'm referring to the pin numbers as the numbers they appeared on that chart that I showed you earlier. You can also import it as GPIO.BCM. That means you're referring to the Broadcom SoC channel numbers, but these sometimes change and are different between different Raspberry Pi models, so I'd recommend doing it using the board style. Then you can see I have a lot of print statements just scattered throughout here. These were just to test. As my script was running through, I wanted to make sure it got to each stage and it would print out the corresponding number showing that it did complete that step. So then you can see me setting up my GPIO pins as outputs right here. And then down here, I'm telling each one to power for 3 seconds and then turn off. So then I can write down which one does which. So I'm just gonna run that script right now and I'll show you what it does. Okay, so here's what happens when I run it. So first, the left wheel goes backwards. Then it's left wheel forwards. And then it's right wheel backwards. And right wheel forward. So you can definitely see how there's a bit of difference of quality of motors, like I said earlier. So I would recommend writing these down, what each one does, and then go back into your program and comment that above. So 29 was left wheel backwards, so I'd comment that right there. And then this one was left wheel forward, right wheel backwards, and right wheel forward. So then go back up and write it up here. So purple would be the left wheel backwards, and then this would be left wheel forward, right wheel backwards, and right wheel forward. And then keep that handy so when you write your actual program, you can refer back to that. So now that I did that testing, I can switch my wires around the way I want it to. So 33 is my brown wire, but I would rather have my right forward be the first pin, which is 29. So I can take my 29 and put it with the 33. So that just means switching out the purple and the brown wire. So then this one will become 29. And then I want my 31 to be right wheel backward. So 31 is my gray and 32 is my orange. So all you do is switch your gray and your orange, and then you would have this crossed out and this would be 31. And then I want this one to be my 32. So you're gonna put your gray there. And then I want this one to be my 33. So I'm gonna put my brown there. So it's just easy enough that you just switch them around and you get to the way you want them. So I'm just gonna do that really quick right now off camera. Just keep switching your wires until you find an order that you like, and then make sure to write it down which wheel it turns and which way it turns it. Then you can get into your code. So you can see I have the same introduction as I did on the other one, importing my modules, setting my warnings, and then here's my little note in my code. So you can see purple is right forward, orange is right backward, gray is left forward, brown is left backward, and those are their pin numbers. I just wanted them in that order: right forward, left backward. That's why I continued switching around my wires until I got that. So now down here is where we're actually making the methods. So I've defined a class robot, and then I've initialized it right here. My parameters self, name, right wheel, and left wheel. So I'm taking in the name Robbie for my robot. So this is Robbie. And the right wheel and the left wheel will be taken in as tuples in the order forward and backward. So you split it up. So I take in right wheel and left wheel as tuples. I split it up. The first element is forward and the second element is backward. And then you do the same thing with the left wheel. Now you have those as variables and you can call them up in your methods. So easily enough, the forward would be right wheel forward and left wheel backward turned on at the same time. Then you stop it, and then same thing with backward. It would be right wheel backward and left wheel backward at the same time. Wait a couple seconds until you stop it. And then your left turn, you just turn on your right wheel forward, and then you wait a couple seconds and you stop. So this sec is a variable and it's put in down here. As you can see, that 3 is my sec. So you can put in whatever you want when you call up these methods. Same thing with right turn, you just turn on the left wheel. So then down here is where I'm actually going through and using my program. So I'm initializing Robbie as an object of the robot class. As you can see, there's his name. There is his right wheel and there's his left wheel. So here it goes: right wheel forward, right wheel backward. And then left wheel forward, left wheel backward. So that's why I switched around the wires a bunch, because I wanted it in that order. Obviously, it doesn't really matter. You can change whatever in your code. So instead of switching around the wires, if you didn't want to do that, you could switch around things in the code just as easily. Then it's easy as calling those methods up, and it should run perfectly. And I'll insert a clip of my robot running right now. A recommendation I just want to add is, whenever you're not using your robot, it would be a smart idea to either take all the batteries out or pop one of them out just to break that circuit, as you can see, because you don't always want current running through it and you don't want to burn up the battery super quick. I hope my tutorial helped a little bit, and thanks for watching.